In this tutorial, I'm going to show you how to make this simple to-do app using Python and the GUIPie library. So if learning Python is on your to-do list, let's get started. Before we begin, we need to make a plan for what our application will look like and how it's going to work. This could be done with everything from pencil and paper to using dedicated prototyping software. On the GooeyPie website, you'll find this PowerPoint template for Windows and Mac with various shapes representing the widgets available in the GooeyPie library that you can copy and place to design your user interface. My initial idea for this simple app is to have an input to enter new tasks, a list box to display all tasks, and a second list box for completed tasks, so you can look back at how productive you've been. Planning the screen layout like this can also help you decide on or refine ideas you have about the different functions of your app, and you can get feedback from others about its layout and design. In my final design, I've gone with a vertical layout and reduced the number of buttons to just 3. New tasks will be entered by pressing Enter on the keyboard, and tasks can be moved between the To-Do list box and the Done list box by double-clicking on the task. Once your prototype's done, save it out as an image and create a new Python file. I'm calling mine todo.py. And I'm just going to drag the prototype off to the right-hand side so that I can have it for reference, which will be important as I set up my app. We'll start by importing the GUIPie library, and then initializing the main app and window with a call to GUIPie app, passing in a string for the title of the window. The first thing we need to do is create all 9 widgets that appear on our app. Starting with the new task label, the first argument when creating a widget is always the window or container to which it's being added. So for all of these widgets, it will be the app variable we created above. And then we need the text on the label. Next is the input for entering new tasks, the label for the to-do list, and an initially empty list box to store all of our tasks. For the buttons, we need to pass in the text that appears on the button, but also the name of the function that will be called when that button is pressed. We haven't written that function yet, so for now we're just going to use none. We'll do the same thing for the All Done button, the Done label, the Done list box, and the Clear All button. You'll notice that I've been using suffixes in my variable names for these widgets, so LBL for label, BTN for button, and I find this useful when referring to these variables later on in the code. With our widgets created, it's now time to add them into the window. The first thing we need to do is to define the dimensions of the layout grid, and we can see that we need 5 rows and 3 columns, where the input and list boxes will each span across 2 columns. And so we call app.setGrid and pass in the number of rows and columns that we need. And now we can add each widget to the window by calling app.add, specifying the widget, the row it belongs to, the column it belongs to, and any other layout options. In this first one, we're adding the new task label to row 1, column 1, and aligning it to the right. Next, we'll add the new task input, which is in row 1, column 2, but spans across 2 columns. The to-do list label is in row 2, column 1. The to-do list box is in row 2, column 2, spanning 2 columns. The first 2 buttons are in row 3, column 2 and 3 respectively. The Done label in row 4, column 1. The Done list box in row 4, column 2, spanning 2 columns, and finally the Clear All button in row 5, column 3. Well, that's a lot of code to write without running it, so let's call app.run as our final line, save and run the code. So we can see that all the widgets are in their basic position, but it's not quite what we expect. What's happening here is that the input and the list boxes have their own natural width. We need to tell them to stretch as far as they can within the space that they're allotted. So that means setting fill equal to true in the layout options. If I Alt or Option click, I can put down multiple cursors alongside the input and both list boxes. And then I can just type fill equals true once. And if we save and run the code, we can see that our input and our list boxes both take up the full width. And that's looking a bit more like our prototype. I still think the whole thing is a little bit too narrow, so I'm going to go up the top and set the width to 400 pixels. Save and run that, and that looks okay, although there is too much space for these labels in that first column, and the buttons don't take up their full width either. So I'll tell the buttons to take up as much space as they can by adding fill equals true as part of their layout options. Now the reason that the labels have all that extra space is because all columns are given the same weight automatically. So I need to change those by calling the setColumnWeights method. And if I pass in a 0 for the first column, then that column won't grow. And if I say 1 and 1, then the remaining 2 columns will grow evenly together as more space becomes available. So that's now worked when we first open the app, but it also works when we resize it horizontally. However, we're going to have a similar problem when we resize it vertically because every row is being given the same amount of space. So we need to go back to our code and change the row weights. So what we want to grow when we go vertically is just our list boxes. So that means the first, third, and fifth rows are not going to grow, so they're going to get a 0. And if we say that both lists want to grow at the same rate, then we'll just give those the number 1. So 0, 1, 0, 1, 0 for 5 rows. Save and run the code. And now when we resize, well, we're getting the right amount of space, but we haven't told those list boxes to grow vertically. The way to fix that is to add the layout option stretch equals true to the end of each of those list boxes. Save and run the code, and hopefully all is well, and there we go. So now no matter how we resize the app, it resizes in a sensible way. The buttons don't get any extra vertical space. The list boxes get all the extra space when the window gets larger. Time to start adding some functionality to our app now, and the first thing we're going to implement is adding a new task into the to-do list. So we're going to type into that input, press enter, and that new task should appear in our to-do list. To do that, we need to set an event listener to that input. We want to listen out for the key press event, and every time that occurs, we want to call the function addNewTask. So now we need to go and write that function, so scroll to the top of the code and define a new function. Now being an event function, it will be passed an event object, and we're going to need to look at this event object to determine which key was pressed, because even though this function will be called every single time a key is pressed, we only actually want to do something when it's the enter key that's been pressed. I'll just add a triple quoted string here as a comment for the function. So that key information will be stored in a dictionary, which we can access with event.key. But with keys like enter and shift and alt and control and some of these other modifier keys, it's worthwhile seeing how GUIPie represents that. So what I'm going to do is print it out, and that way I can do a test and I'll see the results in the console. So I'll save and run the code, and I'll just go into that input and I'll just start typing. If I scroll down into the console, that's the letter A, there's the letter B, there's tab, and when I press enter, then you can see there how it's being represented with its key code name and code. So it's actually given a name of return, which is what the key is on the Mac, incidentally. So I'll use the name of the key, and I'll just start this function with an if statement. I want to say if event.key, the name of it, is equal to the string return. Then what I want to do is add the contents of that input into the to-do list. So I call the addItem method on the to-do list box, and I pass in the contents of the input, which is the .text property. So let's make sure that works by saving and running the code. Type in eat, and it does get added to our to-do list. Type in sleep, and that also gets added out to our to-do list. But what we are seeing is that the text that we enter remains in that input. That doesn't really make a lot of sense. So I'm going to call the clear method on the input. And that way the input will be cleared as soon as we press enter. Typing 8, so that hasn't worked. If I go back to my code, it's because I need to call it on the input, not on the text property of the input. And sure enough, if I scroll down, it says that you can't call clear on a string. So that is now working. As a small quality of life improvement, I'd like for the focus to be on the input box as soon as we launch the program, so that we're ready to type in our to-do lists and get underway with our productive day. So for that, just before we call app.run, I'm going to scroll down and call the focus method on that input. And that way, when I launch the program, that input has the focus and we can start typing straight away. Just a bit more testing now, and I'm realizing that we can just press enter in that task input box and an empty task will be added to our list box. So I'm pressing enter a few times here, and then when I enter another task, it appears down the bottom because I've actually entered in a bunch of empty tasks. So I think I'd like to prevent that. So I'll come up to that if statement and I'll check both that the event name is returned, but also that the new task input text is not nothing. And this way, when I bash the enter key for whatever reason and the task is empty, then I won't get an extra task added. Let's now add the ability to move tasks between the two lists by double-clicking on them. For this, I need to attach an event listener to both list boxes, and this time I'm going to set the event to be the same function for both. And inside that function, we'll work out which of the two widgets initiated the event, and then we can act accordingly. I've called the function moveTask, so we'll go up the top and define that function. So we can work out which widget called the event by looking at event.widget. So if it was the to-do list, then I want to move the task that's currently in the to-do list to the done list. So I'll do two things in the one line of code. I'll call the addItem method on the done list and pass in the removeSelected method of the to-do list. So removeSelected will both remove and return the currently selected item in the to-do list. So if it wasn't the to-do list which was double-clicked on, it must have been the done list, and so I basically just have to do the reverse. So in the else part of this statement, I'll just say to-do list.addItem done list.removeSelected. Save and run the code, add a few tasks, and I should be able to double-click between the two lists to move them back and forth. Let's turn our attention to making the buttons work now, and the first of these is the delete task button. Maybe we've been too ambitious and we just don't want to have that task sitting in our to-do list. We're not going to get it done, so we need it to be gone. I'll go down to where I first created that button and change the none to the name of the function I want to be called when that button is clicked. Now that function that I've named delete task doesn't exist, so we'll go back up to the top and define it. Because it is an event function, we will be passed the event object, so we need to include that as a parameter. The code is pretty straightforward. We are just going to call the removeSelected method from the to-do list. Save and run the code, and we'll see if this works. Add a few tasks: eat, sleep, study. If we decide that we are not going to be able to sleep, then we delete it. But really, we should definitely sleep. Clicking the All Done button will move all of the tasks in the to-do list to the done list. So we'll write a function for that. I'm going to call it All Done. There's a few approaches we could take to getting this done. We could loop over all the items in the to-do list, remove each one and add it into the done list. But another way we can do it is to just add what's currently in the to-do list to what's currently in the done list. So we'll say donelist.items equals donelist.items, what's currently there, plus to-do list.items. So in Python, the plus operator works with lists to join them together into one larger list. So now I need to associate that button press with that function. So go down and write the name of the function where we created the button. Now we can test our code. Add a few tasks. I can still move one task to the done list by double-clicking on it. But if I click the All Done button, they should all move down to the done list, which they do, but of course I'm left with the problem of them remaining in the to-do list. So to fix that, I need to come down to the second line of the function and just set the items in the to-do list to the empty list. And now when I add some tasks and click the All Done button, down they go. We're up to the very last function. I'm going to call it Clear All, and this button removes everything from the done list. This is a pretty straightforward one too. We're just going to take the contents of the done list, so done list.items, and set it equal to the empty list. Don't forget to associate that function with the button, and then we can test our code to see if it works. So we'll add some tasks. We can double click them to move them into the done list, and when we click that Clear All button, the done list is emptied. So thanks for watching. I hope you enjoyed this tutorial. Keep an eye out for a future video where we'll add the ability to automatically save our lists, and I'll see you in the next one.